Hello everyone, welcome to my channel Cloud and Data with Kosha. So in the previous session, we already discussed the PCA implementation part on our actual data set, right? So that part I have already covered in the previous session, and from that I will continue this session, right? So in this session, what we are going to cover that we are applying the XGBOOST model on our data set, right? So before applying the XGBoost model, we have to see some kind of architectural part of XGBoost. And first we have to know why I am going to use XGBoost model. So that is the first use case, right? If you are going to apply any model, so you have to know the intention behind that, right? So why I am going to use the XGBoost model and what is XGBoost concept, right? And please, in between, please confirm that you are, I am audible, right? Yes, yes. Are any doubt? Okay. So XGBoost is, as per my experience that I can share. So XGBoost, it's called extreme gradient boosting, is a popular and you can say it's a powerful machine learning algorithm that belongs to the assemble learning family. Okay. So when I'm going to use XGBoost, and it's a particularly, you can say, well suited for both regression and classification. That means we are using the XGBoost model in regression problem statement and also the classification task. Okay, so I'm just write over there and then you can understood. So my screen is visible, right? Now predict XGBoost, but before that I am just going to add some detailed behind that of XGBoost model, right? So just write XGBoost, that also called extreme gradient boosting technique, which is popular and powerful machine learning algorithm. Okay, and it is first that can 1 minute, so that I can use in this way, so you can understand. So first point is XGBoost or extreme gradient boosting technique, or you can say in this way, which is popular and powerful machine learning algorithm. Second point, second keynote, that it belongs to it belongs to ensemble learning family. And we also know this thing, the use case which comes under assemble learning family, and it is well suited for both regression and classification task. Okay, this is the three main points that I added over here. Okay, so XGBoost or extreme gradient boosting, it's a popular and powerful machine learning algorithm. First keynote. So extreme gradient boosting, which is popular and powerful machine learning algorithm, it belongs to ensemble learning family, and it is well suited for both regression and classification tasks. And some key concept related to XGBoost. First is that gradient boosting. I'm not going to discuss gradient boostings, all the thing. I focused mainly on the XGBoost kind of things. Okay, so we can write XGBoost is an implementation of gradient boosting. A boosting technique. That builds an ensemble of quick learners and usually taken the decision trees. Okay, model sequential that we can know. Okay, and here each new learner corrects the errors made by existing ensemble. This is a gradient boosting. Second point that I also add the objective function. Objective function. Okay. This is another keynotes. Third keynote is that I'm not going to elaborate these things. Only adding the gradient boosting part. Okay. Other things you can also learn. Objective function. Also, the concept is that regularization. Regularization. And D, that point is gradient descent optimization. Gradient descent optimization. And last point, we can say parallel and distributed computing. This is some concept, and when I'm going to apply this thing, we also know that classification and regression task, when we apply, just I'm going to write. So this is, I will take another cell and also write this thing. When we can apply XGBoost in ML, that we have to know. First point is that already told classification and regression task. Second, we have the structured data. That time we can also apply. We have to choose this thing. And Third point is that feature importance. That is also important point, feature importance. Fourth point, I can say larger data set. Large data set. So like XGBoost computational efficiency, we can suitable for large data set. Like you are predicting the stock market data. That time you can also use the XGBoost. Okay. And it often outperforms other algorithms in terms of both speed and accuracy. For wherever my data set is large, that time we are going to use that XGBoost model. Okay. So I hope that the concept we can understood this XGBoost model concept, right? When I'm going to apply, what is the XGBoost use, all the use cases, right? That I have used over here. And next, I am going to show on the normal use case, not my actual data set, but how the XGBoost model works. I am taking the iris dataset, and in the iris dataset, I am taking the breast cancer data, and on that top of this, I am using the XGBoost model. And when it will done, then I will use my actual dataset. Okay. So first we have to input the necessary libraries. Input the necessary libraries. Okay, import XGBoost as XGB. You can input the XGBoost model. Next, you have to import sklearn dot data sets. Import your load breast cancer data. Load, you can see there are lots of data sets, so breast cancer data. And from sklearn dot model selection, and you have to import train test, that everything is available in the sklearn site. Okay, so if you want to explore more on this kind of things, so I'll suggest the sklearn libraries. So you can write sklearn XGBoost means sklearn dataset, load breast cancer, model selection. So everything will be available over there, and you have to import from sklearn dot matrix. You have to import the accuracy score. Import accuracy score. Okay, these are the five that libraries that I'm going to import over here, and I'm applying the XGBoost model on the breast cancer data over there. Okay, so just so all the libraries input that I have done, and next what I'm going to do, I'm to load the breast cancer data set as an example. That I'm going to over here. I have the data is equal to your load breast cancer data x is equal to data dot data. No, there are many use cases. Not a breast cancer data is not the largest data set, right? I've just understood that XGBoost model, how it performs, means how it works, and the classifier model, right? That I'm going to use. That the reason I'm choosing the XGBoost, but the normal use case, or you can say it's just an example. There is no meaning with my actual data set. Okay, so that example, and I'm going to add these things. Your data is added and you can add your data, not your target. So you have add all the things. Now go there and you have to split your train test model. Write train underscore test underscore split and you have to add x comma y comma test size, that is your 20% data, and random state is equal to this value, and you have to assign this in x train, x test, y train and y test. Okay. So you have to split x and train with the help of train test split. Okay. So just add one comment, split the data set into training and testing data, into training and your testing sets. Next, what I'm going to do, I'm to create the classifier. Now I am going to create an XGBOOST classifier. That I am going to use the XGBOOST classifier over here. So you take the classifier, this model, you just write classifier is equal to your XGB dot XGB classifier, and you have to add objective is equal to binary logic, comma, you have to add the random state this value. Once it's done, so my classifier I have created, and you have to print your classifier. Now you can print your classifier. So print your classifier. Just copy the classifier over here and you have to print. Now you can see one constructor data that has been coming, right? So this is my model is coming. There are lots of parameters: booster, callbacks, base code, importance type, random state, n jobs, n number of parameters they are providing. XGBOOST classifier, right? Now simple step, I have my train my model. Now I am going to train the model. Okay, so just take classifier dot fit and x train comma y train. So you have to fit your model, classifier dot fit Okay, your model, you have to feed that x10 and y10. Next, what I'm going to do, you have to make prediction. Now I am going to create the prediction on the test set. Okay, you have to predict. So y underscore pred is equal to, you have the classifier dot predict and you have the x test data, right? And your y pred will be ready. Prediction print, you can use y pred your prediction will be ready. Now I'm going to create the prediction on the test data set, right? So this is the type is, so I have to see the type of my prediction data, right? To see the type of my prediction data. But you write print, you can as type y print. Okay, and you have to evaluate your model. Now you can evaluate your model. Okay, accuracy score, you have to add accuracy score of your model, that you have to check first. You have y test and you have y print, and that's all. So just print your accuracy. Now you have to print, take the if function, take the if string to print the accuracy. Okay, just you add accuracy and you have the accuracy model and you have the data what they are. Okay, now you just 94%, that's quite good, means above the 80% means that is a good accuracy they are providing. And that's all for that XGBOOST implementation of my that inbuilt dataset of SKLearn, right? That are part. Now this XGBOOST model I am going to apply in my actual problem statement. Okay, this is the example, so you can understood the example part. And now I am going to perform XGBOOST in my actual data of this problem statement. Okay, do one thing, you already imported this thing, but before going to apply I want to see the architecture part that I have to show. So just go the XGBOOST architecture, you can write, and you can see the XGBOOST architecture, how it is works, right? Like you can see the data set. So this is my data set 1, data set 2, data set 3, and they have to aggregate the result. You can see they have the data taken from the decision tree model. Okay, so in between the data set is supplied to the decision tree. Okay, and that residual part they have taken and they have created the result, and this result they have aggregated the sum of result, and that is the final result. So this is sample data you have to construct of decision trees. For decision trees you have to create the construction of decision trees. This is the construction part, that tree 1, tree 2, tree 3, right? There are many kind of decision tree model will be there. Okay, you have to create and then you have to aggregate the decision tree model. They have different results that they are coming, right? And you have to aggregate the output. And many same use case means there are different architecture, but they are using this thing like classifier one, they have label data set. This is a parallel distributing part they are using. Okay, k-mean clustering they have to use, and the classification model, the architecture of XGBoost and TSBO, the two model they have taken, but mainly you have to identify that XGBoost model, right? And you can see also this is a two-layer XGBoost algorithm. Okay, so they are aggregating and they have to bagging, that is will classify. Okay, this is the original data and you have to divide it, the classifier with the decision tree, right? So you have to classify one format, classify two format. You can see and then they have to aggregate and the bagging. So bagging boosting that I'm not going to cover in this session, but the XGBoost part, this is the architectural part. Okay, so you have to cover these things. Okay, there are many architecture you can see. Mainly they are using the decision tree model. Okay, the XGBoost. And also you can see the structure. This is the different that XGBoost and different model, model, that is different thing. And this is the big data part they have to taken, and they have transformer, estimator, they have to feed the model and they have to train this model. And you can refer these diagram techniques. Okay, so I have already this thing means this is the architectural part that I've shown. So from the picture we can understand, right, what is going to cover. Okay, and now let's go to come back to our actual problem statement. So we have to already imported that XGBoost, XGB and train test split. Now I have to add the mean square error. Okay, so now write from sklearn dot matrix to import R2 score, and you have to import mean SU, mean square error, and you have to import from math, you have to import SQRT. Okay, square root function that you have to add. Now you have to run. So import the rest of the libraries part. Now what I'm going to do, the 10 test split I have taken, right? Just write train underscore test underscore split that I've already taken, and you have to add your train data feature, train underscore data underscore feature underscore trans, and train so to add train data target test size that is also use 0.3 and random state 40. Then data target is there. Yes, so that I have to split. These of the parameters you have to take, okay? And you have to add this thing in your X train and Y train, this model, right? Like train X, this takes any name you can take for your understanding purpose, okay? Train Y and test underscore Y equal to this value. Just run. So your 10 test speed is done. That I am going to add, okay? Now I can print. So split our model, split our train and test data with the help of train test split, where test size 0.3 30% data if for testing, and random state is equal to 44. That part I have done. I have to print the 4 data shape. So print my print X data shape, train X, train underscore X dot shape. Y shape dot Y dot shape, and you have to tell next my test X data shape, that is test, apply test X, and then you have to copy this line and you have to print. So you have to add test Y, test Y save. Now just click on this button and you can see 2946 rows and 6 columns of the test data, and obviously the data for kept for that 1296. Why? Because just going to calculate 0.3% 2946 into 30 by 100. And that can be 0.3. No, total value is how much? It is, yes, so 1263 you can see. So this is my 2946 what? 2946 is my training data. 1263 is my testing data. My entire data is 2946 plus 1263, and I kept 0.3 means 30% for testing size, testing purpose. And your actual value, that might be your 1 to 60. So you apply print, you have this data, right? One to 60. Now we have to use that part. That part is done, right? 10 test split I have done. Next, what I have to do, I can use these values. First write over there. XGBOOST hyper parameters tuning manually. Okay, so you have to create that regularization part. So write XGB underscore regularization, and you have to take XGB dot XGB regression. So objective is equal to, you have to take regulation here, and you call sample by tree. So decision, these trees have to take by tree is equal to 0.3. So just write XGB regression. You just go over there and go your Google. And you can go to the documentation. Okay, so everything is there for the XGBoost model. You can see you have to import this way, you have to set your parameters, you have to set your like you have to want to debug, then you have to add this verbosity level. So all of the things you can got in this website, right? So I just prefer this website for XGBoost ready read the docs.io. So you can get everything the kind of API. Okay, this is the parameters, right? You can see training the model, test the model, everything is there. So let's go to our main structure, and you have to add. And then you have to add the learning rate. Learning rate, that is your 0.3%. Okay. So call sample by tree, that is also 0.3, and learning rate 0.3. So as per the use case, you have to take this value. Okay. So in my use case, I saw that learning rate 0.3 standard for that. So model can learn from this data set, right? From this thing. So I have added these parameters over here. Okay. So this is called that hyperparameters tuning of XGBoost that I have to add. Then you have to create your model is equal to XGB regression this value, and you have to dot fit, that is your train underscore x and train underscore y. Just run this and your model is prepared. Now we can see that model. So print your model. Your model is done. Exactly whatever I have done in my scalar data set that times. Same model I have to fit with my train and test. This is my train data set. Model will be fit. Model will be fit in the train data set that I have to write. So you have to add your learning parameters over here. Now we can create our model which is given XGB underscore dot fit, and you have to provide this train underscore x and train underscore y is value, and your regression model is creating with call sample by tree and learning rate. Okay, so it's done up to that part, and you have to take it to model. Now next part is that you have to print the roots mean square error. So that will be the next statement that I am going to prepare. So print your RMSC model root mean square SQUARE roots mean square you have to prepare, right? Equal to SQRT, and you have the mean square error. This mean square error I have to remove here. 1 minute, mean square error. Just go and paste this value, okay? And your model is ready. Model dot predict, and you have to supply test underscore x comma test underscore y and run. So your roots mean square error, that is 12.24. Okay, that's quite good. I think that now you can write here RMSE is 12.24 or 25 approximately after tuning, because I have done my tuning part, right? Tuning the hyper parameters to attain minimum RFSC. This statement I can add. Okay. As of now, we are okay, right? Now we have to prepare the plot. So we have to see that graphical format, these records, right? So I have done the model part. We have to predict the model. We have to create the predict test, right? So we have to prepare and we have to show the chart. So import part we have to import so that we have to import the matplotlib. We already know these things. Matplotlib dot pyplot as plt. That is good. Import your seaborn, okay, on top of the matplotlib as SNS. That's good. And you have to create your print test. Print test is nothing but print test y is nothing but your model dot predict, and you have to separate test underscore x. Once it is done, or you can do one thing, you can print. So do one thing, input your library. So I am breaking down all the things. So that part is import the libraries. Now you have to add create test. You have to create a prediction create test y. So model predict, and you have to print this create test y. And now what I'm going to see, model print test is done. You have to take other cell over here, and now I'm plot. And 1 minute, I think. Yes. So now what I'm going to do, I create the plot. plt.figure create the plotting figure. Quick size that is my 10,5, and sns dot displot. You have to create your distribution plot, and that is test underscore y. And test underscore y 150, color you can take yellow. You have to take your label equal to actual value. Okay. SNS dot list plot, and you have to add print underscore test underscore y, which nothing was this value print test y, and that also be conditional, that print test y 150, color that is purple or red, any color you can take the color purple, and you have to add your label that can be predicted value, predicted value, and you have to display plt dot type dot layout. Now I am going to click this cell and see what happens. Our distribution chart, I think, yes. This is creating, right? Tight layout is combined, but I think why it is not coming. Tight for layout, I think 1 minute. Yes, now it's coming. Okay, the distribution you can see, right? The chart distribution we are also saying. So that color for the whitest value and this is the actual value, right? Label I am taking. So now you can see there's the figure, the chart distribution that is coming, right? So my fixed size that I have taken and this plot and also I am creating this distribution. So you can get some kind of idea, the distribution chart, right? It's not a fully bell curve diagram. Something is left skewed and something is right skewed is there in this data, right? And I hope is now you can understood. And next part that I'm going to use, I have to optimize more, so I have to use the k-fold cause validation. So I have to work on k-fold cause validation using XGBOOST. K-fold cross validation only. So as usual, I have to make the concept first. What is k-fold cross validation, right? And then once we can understood, then we can use this part. Any questions? So you have to, you can say it's a technique, right? In the mill to assess the performance of a model and reduce the risk of overfitting. So you have to fold, k fold, k means your number, right? How many folds you have to create, right? So I'm writing these things. So k fold cross validation, k fold cross validation is a technique used in ML or machine learning to assess the performance of a model and reduce the risk of overfitting. Okay. So the data set we have to split into k folds. So we have to k means how many folds you have to create. Instead of learning all the data, the training data at a time, we have to create one fold. So you have to structure, you have to clustering that data, right? Group. You have to create the fold of cross validation. And then you have to prepare the data. And the model is trained. So instead of giving large values, we have to cluster it. You have to divide it. I have 10 GB of data or 100 GB of data. So you have to create three separate things. 30 GB, 30 GB, 30 GB. Okay. You have to create the fold. And then you have to use the model. And we can evaluate k times. K times means number of times. Each time we have to using the different fold as the test set and the remaining folds as the training set. So you have to alter. Once the test set is done, this test set will be another fold of training set, right? And then it will be, you have to create the model. So the data set, I can write the data set is split into k folds and the model is trained and evaluated k times, and each time using a different fold as the test set, okay? And the remaining fold as the test set. Remaining fold as a training set. The performance, you can write over here, the performance metrics, we have to create the performance metrics, right? Are the average over the k iterations. Okay, and we can see that k-fold architecture over here. We can see the image and diagram. We'll go there. K-fold. You can see. Yeah. So in model performance, you have to split data set into training and test, right? We have done these things. And split training data set into k folds. And you have to use k minus 1 folds for the training. So this training data they have to prepare. Okay, so you can go this block they have already given. And always leave one fold for test. You have to keep one fold for test and take care of transformation in that fold, okay? And find the accuracy of the model. So you can see this is the value, right? So this is the architecture I can prefer, and you have to create the model performance. This is used for the model performance using optimization techniques of k-fold, okay? That thing I am going to use over here. And you have to write. And is equal to your XGB dot D matrix, and you have to add your data. You have to supply your data. That is my train data. Train underscore data underscore feature transaction, that is my data source. You have to provide, you have to create the a full cross validation with XGB. XGB. You have to add the value and you have to add your label is equal to your train underscore data underscore target. This value, okay? And your parameters you have to provide as a dictionary form. So I hope everyone can know the concept of dictionary. That is the key value pair. You have to add this value. You have to add your call sample binary. That is your 0.3. You have to add your learning rate, learning underscore rate. That will be your 0.3. So learning rate you have to add, right? And then you have to create the model underscore CB, that is XGB dot CV, and you have to add your D train is equal to your D matrix train. So you have to add your training data over here to prepare the models. And params is equal to add your params. These params you have to add over here. You have to, I've created n folds. So 3 folds I have to create n folds. You can see n fold that can be 3 and num boost round, that will be your 50, and one parameter that I have to add over here. This is my early stopping round 10. Okay. So early stopping round, that is 10. Once it is done, so I have to just the model CB. Now my model CB is done. I have to print my model CB. How this looks like model CB cross validation. Okay. Now you can see that cross validation, all the data are coming. Train, mean, the RMSE square, standard deviation, mean square, test, and training data. So and I have to print all the data set 34, right? And print the tail data, print model underscore CB dot tail. So last 2 rows I am going to see over here. 34, and I want to see the cross validation table last 2 records. So I hope we can understood up to this way, and one statement we can add by using a fold cross validation RMSC is reduced approximately 10%. That's something optimized, test well, right? 10% reduced. My RMSC how much? RMSC, that is my 11. Point something, right? This is my RMSC score for the test. So we have using the K fold, the approximately reduced 10% over here. Okay. And now I'm going to close this session over here. Next video, and I'm going to use the prediction of the test data. Okay. So I hope you can understood this way. And if you have any doubts, so please let me know. If you not understood the RMSC or that how it can be reduced. So I'll discuss elaborately this thing in the next video. And thank you for joining the session. And please subscribe my channel so it can boost my confidence and we can grow and learn together. And that's all. And thank you for joining the session. If you have any doubts, please let me know in the comment box so we can definitely address your concern. And thanks for joining the session.